Hello, I welcome you all to this another interesting screencast, and the problem reads: the two boys push on the gate with forces of Fa equal to 30 pounds and Fb equal to 50 pounds as shown. Determine the moment of each force about C. Which way will the gate rotate, clockwise or counterclockwise? Neglect the thickness of the gate. In the second case, two boys push on the gate as shown. If the boy at B exerts a force of Fb equal to 30 pounds, determine the magnitude of the force Fa the boy at A must exert in order to prevent the gate from turning. Neglect the thickness of the gate. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Alright, so let's try and create the space first and foremost. Then let's begin the work. Starting with case 1, which I'm calling case 1 is a 4-13. We are being asked to determine the moment of each force about C, and then later on determine which way the gate will rotate, whether clockwise or unclockwise, and we are to neglect the thickness of the gate. Alright, so before we do so, we need to divide this particular force into its components along the x and the y. Let's start with Fa. Fa will have a component in this direction, like so, and then there will be another component in that direction, like so. And then Fb will have also a component in this direction, like so, and then it will have another component in that direction, like so. Okay, all right, so now what do we have? So this one here, we are going to call it Fb. We've been told what it is. Fb is equal to, so we've been told Fb for case, we are looking at case number 1. Okay, let me just write it as Fb. I just write it like this so that, because there are two problems here, so just write it as Fb sine 60. Okay, and then this one will just say Fb cos 60. Then this one will just say Fa, since we have two problems there, so that we don't keep on rubbing. This one will say Fa times the rise, which is a 3 divided by 5. Then we'll say Fa times the run, which is a 4 divided by 5. So with this information, we can now label each case here. So we know that our Fa for case number 1 is 30 pounds, and Fb is 50 pounds. Therefore, if we are to work out the moments at A, we'll say, so we are looking at the force due to Fa, so moment due to Fa. So say summation of moments about point C. Maybe I should put on top here, I would say moment due to Fa. Okay, moment about point C due to Fa. So we'll say summation of moments about point C anti-clockwise being our reference is going to be equal to, this is due to FA. We have clockwise, which is negative, so minus FA 3/5 times the lever arm, which is a 9. Okay, and therefore this is going to be equal to FA itself, we said is 30 by 3/5 by 9. So this gives us, where's my calculator? We have a 30 by 3 by 9 divided by 5. So this gives us a 162 pounds feet. Okay, so this moment is this summation of moment is equal to 162 pounds feet, and it is clockwise. So clockwise is like this. So this is the first case due to FA. Okay, this is due to FA. All right, let's look at moment about C due to FB. Okay, so again we'll say summation of moments about point C and clockwise being our reference due to FB. What is FB? This is going to give anti-clockwise, which is a positive, so we say FB times FB sine 60 times the lever arm, which is 6. Okay, and then we know what FB is. We said FB is equal to 50 sine 60 times 6. What does it give us? So 50 sine 60 times 6. This gives us a 259.81 pounds feet. Right. So this can also be written as the summation of moments due to FB is a 259.81 pounds feet, and it is in the anti-clockwise direction. This is anti-clockwise, right? Great. So now let's compare the two moments. Let's look at this. Look at this moment and look at this moment. Which of the two moments is bigger? Which ones? Of course, it is this one, right? It is this one, right? Great. Therefore, which way will the gate open? The gate will rotate. It will rotate counterclockwise. Okay. Why? Because the moment due to FB is bigger. All right. Is that fine? Great. All right. So let's go to case number 2, which is case 4. So I'll say therefore the gate will rotate whatever. So case 4-14. All right. So again, here is the same two boys, but in this case, they are telling us that FB is equal to 30 pounds. We have been asked therefore to determine the magnitude of FA the boy at A must exert in order to prevent the gate from turning. So we are going to sum up all the moments about point C due to FA and FB to find FA. So FA is not known. That is what we want to find. Okay. So what we are going to do is we are going to sum up the moments at, we are saying moments about point C should be equal to what? 0. Okay. So we'll say summation of moments about point C and clockwise being our reference should be equal to what? 0. So we'll sum up the moments being caused by FB and FA and you should get a 0. And when we have a 0 moment at C, then it means that the gate will not do what? It will not rotate. It will not turn. Okay. All right. So there we go. Let's start. So we have FB sine 60. This one is giving us anti-clockwise, which is positive, by the lever arm 6 minus FA by 3 divided by 5 times the lever arm, which is 9, is equal to 0. But we know what FB is, so replace FB here. So once we do so, then we'll have a 30 sine 60 by 6 minus FA 3 over 5 by 9 equal to 0. Therefore, our FA will be equal to, let's do the calculations. So we have 30 sine 60 times 6 divided by 3 times 9 divided by 5. So FA is therefore going to be equal to 28.87 pounds. Okay, I repeat again. So 3 over 5 times 9. Then we have 30 sine 60 by 6, then that divided by answer 28.87. So this is the value of FA that will cause the summation of moments about point C to be equal to 0, or this is the force of FA that will make the gate not to turn. All right. This is really about it. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.